Hello everyone, I am a BSc second sem student Bhagyalakshmi Gangar studying at SSGFGC College, Nargund. Today I am discussing about the VSEPR theory, contents, definition, postulates, structure of molecules, shapes of ions and references. Definition: the presence of non-bonding electrons in the valency shell of the central atom of the compound decides the geometry of the compound. Postulates: first one, the electron pairs repel one another and try to stay as far apart as possible for the maximum stability of the molecule. Second one, a molecule has a regular shape if the central atom is surrounded by only shared pair of electrons. And third one, if the central atom contains one or more lone pair of electrons in the valency shell, the geometry of the molecule is distorted. This is because the repulsive interactions decreases in the order lone pair is greater than lone pair bond pair is greater than bond pair bond pair. Structure or shapes of molecules. NH3 molecule. The outer electronic configuration of nitrogen in its ground state is 2s2, 2px1, 2py1, 2pz1 according to the Hund's rule. In ammonia, nitrogen atom undergoes a sp3 hybridization to produce 4 equivalent orbitals. Out of these 4 orbitals, one has a lone pair electrons. The other 3 orbitals containing unpaired electrons overlap with 1s orbital of 3 hydrogen atoms. These 3 atoms of a hydrogen occupy the 3 corners of the tetrahedron. Next one. Due to the higher lone pair bond pair repulsion, the molecule gets little distorted and the HNH bond angle decreases from 109 degree 28 minutes to 107 degree 30 minutes. Thus the shape of ammonia molecule is pyramidal shape. H2O molecule. The outer electronic configuration of oxygen in its ground state is 2s2, 2px2, 2py1, 2pz1 according to the Hund's rule. In water molecules, oxygen atom undergoes a sp3 hybridization to produce 4 equivalent hybrid orbitals. Out of these 4 orbitals, 2 contain a lone pair of electrons. The other 2 orbitals containing unpaired electrons overlap with 1s orbital of 2 hydrogen atoms. These 2 atoms of hydrogen occupy the 2 corners of the tetrahedron. Thus, in H2O, the central atom of oxygen is surrounded by 2 bond pairs and 2 lone pairs. Since the lone pair repulsion is more than the lone pair bond pair repulsion, the molecule gets more distorted and the HOH bond angle decreases from the 109 degree 28 minutes to 104 degree 30 minutes and shape is V-shaped or bent shaped. Next, structure of a H2O molecule. Bond angle is 109 degree 5 minutes. Shapes of ions. Bf4 minus ion. The outer electronic configuration of boron in its ground state is 2s2, 2px1, 2py1 according to the Hund's rule. In boron tetrafluoride, boron atom undergoes a sp3 hybridization and negative charge indicates the adding of one electron, but valence electron of the boron atom is 3. Hence bonding between those is not easily so. We getting adding of one electron, then there is a formation of a 4 bond pair of electrons. Bond angle of boron tetrafluoride is 109 degree 28 minutes. Thus the shape of the tetrafluoride ion is a tetrahedral shape. Next one, structure of the Bf4 minus ion. SnCl6 minus 2 ion. In tin, valence electron are 4. In tin hexafluoride, tin atom undergoes a sp3d2 hybridization. Negative charge indicates that we are adding of 2 electrons, but a valence electron of a tin is 4. Hence bonding between those are not easily possible. So we are getting or adding of a 2 electron, then there is a formation of a 6 bond pair of electrons. Bond angle of a tin hexachloride is 90 degree. Thus the shape of the tin hexachloride ion is octahedral. And structure of a tin hexachloride ion. A reference Shri Vinayak Nayak Sir publications, and thank you.